So guys, I'm bringing in the example here, even though I told you to read it kind of on your own, but there's some of your old friends here that you really didn't like very much from the first semester, especially that dot plot as a simulation, right? So here's the scenario. The population is 200 chips, and it's supposed to be 50-50. That's what the teacher claims. Now, our girl Jenna, I think her name's Jenna, she goes to grab 20 chips, and the red ones are the good ones. It means you get more time in class to work on homework and less time with the teacher just yapping about whatever. And she comes up with 7 when she knows she should have come up with 10. And then there's your phrase, our famous phrase, does this provide convincing evidence? That's going to make so much more sense in 2 chapters, guys. So just keep working with me for a little bit. So what's the evidence that less than half of the chips are, what is the evidence that less than, well, she went and grabbed 20 and she didn't get 10, she got 7. That's the evidence, right? Jenna's sample proportion was 7 out of 20.35. That's less than 50. Now here's the thing, guys. You might just look at those 2 numbers and go, yeah, that's less than that. Something's up. They're not all 50-50. But what you don't realize is sampling variability comes into play. This might happen a lot when you pick 20 of them. It might actually happen a lot that you get 35% because there's no guarantee for regular behavior in the short term, right? Until you heroically do this many times, you don't expect the average of your, grabbing these chips to turn into 50% until you do it heroically many times. What happens on the first time may not be a good indication. So part B, provide 2 explanations for the evidence. Well, either this is weird, and it's so weird that it's convincing evidence that the teacher is lying and it's not actually 50%. Or it's within the realm of sampling variability and it's actually not that weird at all. It could be 50% and she just got 35%. Part C, there's 1 dot on the graph at 0.80. That's right here. Explain what it means. In one of the simulated trials where they took 20 chips, 80% of them ended up being red. Let's see, then would it be surprising to get a sample of 35%? Well, if you look at where 35% is, there's a whole bunch of them here. You can't really count them. There's so many dots that they just kind of blur together. But can we agree that that's bigger than 5% of this picture? I think that's what's going on there. Based on your previous answers, is there convincing evidence that it's less than 50%? We're going to say no because there's a whole bunch of 35% and less. But I can go one further. We learned something last chapter to actually find a probability. I did this with a binomial CDF. We're sampling without replacement, which is a violation of the independence condition of the binomial setting. However, we're taking 20 out of 200, and that's 10%. If you only take 10%, we're okay with the independent condition. So look, I'm taking 20. That's a set number of trials. The probability of success is 50%. Each time you pick one, they're independent. We're randomly picking them. That makes them independent. And the probability of success is 50% every time. Technically, it's not because we're sampling without replacement, but because we are only taking 10%, we're okay with it. So look, I'm going to do a binomial CDF to see if I have good evidence. Where's it? Binomial CDF, and it will be out of 20, taking 20 chips, where the probability of red is 50%, and I want to see if 7 or less, CDF adds up from 0 to 7. I want to see if the probability adding up from 0 to 7 is less than 5%. Because if it's less than 5%, then it is good evidence that this is a weird scenario and those probably are not 50-50. So I hit enter, and it tells me there's a 13% chance. So that's odd that it came up, but it's not good. It's not so odd that I would start calling the teacher a liar. You see what I mean? Before I go out of my way to call this teacher a liar and say these aren't 50-50, I should have really good evidence. And the fact that, according to this binomial CDF, our girl Jenna could have got 7 or less 13% of the time, that's not good enough evidence. We need that number to be less than 5% for us to call out the teacher as a liar. Okay, I wanted to just run through this whole thing because that's a lot of big concepts that we have studied before and have been trouble for you guys. Be careful with the following terminology. A population distribution describes all the values of interest taken by all individuals in the population. A distribution for a sample describes all the values from individuals in one sample. Data that I might get when I take one poll. You might call this a sample distribution. Be very careful. That's not the name of this chapter. This is the name of the chapter. A sampling distribution. You see how the words are so close to each other. A sampling distribution is a collection of all statistics from every possible sample of the same size from the population. Okay? So look, you guys have got to get ready for this test that you're taking tomorrow. And so I'm going to teach this exact same stuff to the B-Day people in class tomorrow. See if I did that right. I think I did that right. And so I'm not going to assign any homework on this. I just want you guys to go to Canvas and enter your two proportions in there. And then what I'll probably do tomorrow is I'll send out one last video where we fill in all that information. And then I'll assign some homework over the weekend for Section 7.1 Day 1. All right. Have a good night.